Hello everyone. Just welcome to our first class. And in this first class, we will cover these 7 topics. First one is what is firewall. Then we will see stateful inspection. Then I'll go for Palo Alto firewall history. Then I'll go for PAN OS. What is the Palo Alto hardware we are having? What are the VM series firewalls we are having? And after that, I will also go for SP3, then packet flow and initial access. These are the topic which I'm gonna discuss today. So guys, like what is firewall? So let me just tell you the definition of firewall. So like firewall is a software or a hardware based security device. It may be a software or it may be a hardware based security system or a security device who can control the traffic or who can inspect the traffic as per the configured rule set. Okay. Rule set means as we are here for Palo Alto class, so that rule set is known as a security policies. What are the information we will define in these security policies? They have an information like source IP, destination IP, source port, destination port, protocol numbers, application, URLs. These are the details which is available into these security policies. So means if I'll see controlling means in that case in controlling means my firewall basically deny or maybe allow the traffic on the basis of source IP, destination IP, source port, destination port, protocol numbers, source zone, destination zones, right? But if I'll say inspect, inspection means it will just scan your traffic for different kind of threats, malwares. If your data is having any kind of threats, any kind of malware or any kind of malicious payload inside it, what it will do, it will just trigger the signature or trigger the threats event, and it will just block the traffic or maybe generate the alert as per the configure rule set, as per our configuration, guys. Okay. So now if I'll write a few major firewalls nowadays, the thing is major firewall which is like Palo Alto is the one firewall. We are having Checkpoint, we are having Fortinet, we are having Cisco, FTD, FMC, we are having Cisco ASA. So these are the few names here. These are the popular firewalls. Okay. And apart from these firewalls, we do have a firewall from Juniper, like Juniper SRX is there. We have a Sonic Wall. We have a Cyber Roam, and we are also having a like firewall from Sophos, firewall from HP, fire from Dell. These kind of firewalls is also available in the market. But if we see Palo Alto, Checkpoint, Fortinet, and Cisco, these are the market leaders nowadays, guys. They are leading the firewall industry. If I'll say like from 2008 till today, Palo Alto is the market leader in firewall industry. So it's just leading the firewall industry as per the Gartner. Gartner is the company who will basically do the continuous monitoring. They will do lots of basically research on the firewalls, which one is leading on the basis of different feature sets with different throughputs with the customer base and all. And according to this Gartner Magic Quadrant, so they will perform these particular, we can say, research and all in every quarter. Okay, and they will just broadcast these results. So as per their results, Palo Alto is the market leader, guys, from, and it is just taking this place from 2008 till today. And if I'll say one thing, like Palo Alto firewall is introduced in 2005, and after in a time of 3 years span it will become market leader. Why it become market leader? Due to its feature sets, due to its architecture. And that's why we are also here for, basically we are, that's why we are discussing this Palo Alto firewall. Okay. So now let me repeat the definition of firewall one more time. Like if you go in any buildings, okay, you will have a security guard, and if you go inside this building, what this guard will do? He will ask so much information, right? And he will check his register. You are the authorized person or not, right? If you are an authorized person, he will give you the access. Otherwise, he will deny your access. You can think firewall is in a similar way. Firewall is a similar device who can basically give the access, or who can basically control the incoming and outgoing traffic. Okay, so let me just go in my whiteboard. So if I'll go there, so if I'll have this kind of topology here, right? So you see, I'm having here this is my firewall, this is my LAN network, this is my DMZ network, and this is my outside network, or this is my internet backbone, where I'm having connectivity with the outside world. Okay, so if you see here, if traffic is coming from LAN and it is going towards the outside, this traffic is known as like outgoing traffic, means the traffic which is going out from your organization. Let's suppose there are few users, they want to access your servers in DMZ zone. Maybe we are having one server, on that server we are running our website. Maybe we have hosted this www.crnets.com on that server, and if people wants to know about us, what they will do, they will just try to access our website. So these requests is coming from outside and going towards the DMZ, right? So the thing is, these requests, basically this traffic is known as a incoming traffic. And my firewall, what we will do, if you see here, all this traffic going through the firewall, right? So means now whatever security rules you will define in your firewall, it will basically control the traffic accordingly. Means it will allow the traffic accordingly, it will drop the traffic accordingly. Let's suppose we are having two users here, PC1, and we are having one more PC2. They are in internet. Okay, let's say we only want to allow the access of our DMZ server from PC1. So what we have to define one security rule: if traffic coming from this PC1, just allow it. If traffic coming from PC2, just deny it or just block it. So these kind of security rules we will define, and according to these defined rules only, my firewall basically take the action, or means it will basically just control the traffic. You can also consider firewall is a like barrier or a boundary between your LAN network and your WAN network, between your inside network or maybe your outside network, between your trusted network or between your untrusted network. So the thing is, sometimes if I use like WAN or outside or untrust or internet, just consider I am talking about the outside always, where the I am having the internet connectivity. If I'll say LAN network or a trust network or an inside network, which means I'm talking about the my LAN segment where my employee systems are there. If I'll say DMZ, it's a demilitarized zone. Means if I'll say the DMZ, which means I'm talking about the zone where I am having the public facing server, or public internet facing server. Means let's take example. Let's suppose we are having this kind of infra. So what I can do, let me just go here. Let's suppose we are having this kind of infra where, let's so I'm let me just design a one. Let's suppose I take example Amazon.in, which we everyone use for some shopping purpose, right? So what they have Amazon having one firewall. Let's suppose it's a Palo Alto firewall. That firewall have a connectivity with the ISP, like this is ISP 01, this is ISP 02. You will see this kind of typical design actually. Okay, this is Ethernet 1/1 interface, Ethernet 1/2. I'm having another interface which is Ethernet 1/3. I'm having web server. I'm having two web server on which I have hosted www.amazon.com. Okay, behind this interface or where I have put this particular server behind our DMZ zone. I have created one more zone, which is my inside zone. Or maybe I will create one, I have one more interface. So this is Ethernet 1/4, this is Ethernet 1/5, and this interface is maybe my server zone, or these are the database server zone. So what? Maybe in inside what? I will put the actual network team. I'm having that network team here who is responsible for maintaining these servers, these web servers and these database servers. I'm having their database servers is there. These are DB server, and also on the same interface behind this, maybe I'm having my F servers, application servers, right? So the thing is, I'll always allow the access of these particular servers to outside people. This is my internet, right? They will always they only able to access the server which is behind my DMZ interface. I will not get the access of my database server or my application servers or my LAN net or my LAN network or my inside network to these outside people, because you will find some good peoples out there. Some hackers is also there, right? Maybe some people are trying to do a business with you. Maybe some people is trying to just exhaust your resources. Maybe they just trying to harm your resources, right? So in that scenario, we will create these different zones actually. So generally, DMZ is a demilitarized zone, or is a zone where we are having our servers or a internet facing server. Because if this particular user wants to access Amazon.com, what he will do? He will basically just send a request over this server. If he wants to, let's say, fetch some maybe article, maybe he's just trying to buy one laptop. So what it will do? He will just give the request. He will initiate request on this server, and now this server will fetch the information from your application server regarding this article. When he will purchase this article, what? Now this particular server will basically write the information into your database. These people, they will not have a direct access of these database servers to write that information. So like that, we will maintain the security, guys. That's why we will always have a like inside zone, which is a most secure zone where we have our LAN users. We will have a DMZ zone where we are having our public internet facing server. Because let's suppose on this server, if we want to run some updates, guys, or let's suppose we want to upgrade this server, what we will do? We have to send that these peoples, because this is our network team, right? They will log into this, or they will do the upgrade. Let's suppose there's a one system, he wants to just access our Amazon.com, what he will send the request. So if you see, DMZ is a zone where traffic from inside internet is also coming and traffic from LAN is also coming, right? So that's why we will give that name as a DMZ. This is not a most secure zone, okay? It's a less secure zone. So this is the concept of like inside, outside, and DMZ, or we can say inside is also sometimes called as a like trust. Outside is called as a like untrust. So sometimes outside is called like internet zone. This is called as like LAN zone. So if I use this terminology during the training, don't be confused, guys. Okay, this is the exact meaning of this. Now let me just move further. So this is the like definition. So firewall is a device who can basically control the or inspect the incoming and outgoing traffic, okay, as per the configured rule set. Now let me just go with stateful inspection. What is stateful inspection, guys? So before, if you want to understand the stateful inspection, you have to first understand what is the stateless behavior. So what I will do, let me just draw a router here. I am having one router here. Okay. Router have one interface which is F0/0, 0/1, and F0/0. Let's suppose this is the outside interface. This is the inside interface. And in outside, let's say I'm having one server one. Let's suppose on this server, it's a web server. So it's running on TCP port number 80. On this web server, I'm having one 2 GB file. This is a MP4 file on this server. Okay. This server having IPA which is, let's suppose, 200.1.1. 100. Okay. I'm having inside interface where I'm having one PC. That PC having IP address 10.1.1.100. On this interface, I am having IP address 250. On this interface, I am having IP address 250. 200.1.1.250, 10.1.1.250. So this kind of setup, let's say I'm having. Okay. So now let's suppose on from this PC, I want to access this server and I just want to download this 2 GB of file. So what it will do? What this PC, he just open his browser and he will type, or he can just type this like 200.1.1.10 and port number, maybe the file of maybe path of this file, right? And he can just start downloading. So what he will do? He will send first request to this server, this router process this request and he will forward this particular request packet towards this one, right? It's a web server, so first they will generally the first packet is your SYN packet in case of TCP, because in TCP they have to do the TCP three-way handshake, right? So let's say it's a SYN request received by router, this router forward this SYN request towards this server. What now server give the reply for this SYN request, or just consider this first packet. Router receive it, he will process it and he will just forward this first packet here. So the thing is, if you see here, when this router receive this packet into this interface, what it will do when he this first packet received by this router, what it will do, it will just put this packet into the ingress process. It will put this in back into the ingress process. It will just check, like it will just parse the layer 2 header, it will pass the layer 3 header and layer 4 header, right? It will look for all this information, it will run the crc. If like fragmentation is happening, it will do the ip assembly, all these kind of things router will perform, right? After that, this router also basically do the lookup on routing table. If we are having policy based forwarding, then it will do the lookup on policy based forwarding table. This policy based forwarding is also known as like PBR, policy based routing in router. Okay. And it will also do the lookup on ceph table, right? This route also needs to perform the ARP lookup, right? Needs to basically, if let's say net is there, then router needs to perform the net, right? So many checks this router will do before processing this packet, right? So the thing in case of router, it will perform around 27 checks if we will use all the features of router. If ACL is there, then it will match this traffic against the configured ACLs on this interface as well, right? So it will perform around these 27 checks. And after that, it will just forward this request towards this server. When this server give the reply, what now router again, he will receive this packet into this interface. So what it will do, again, it will process this packet through all these 27 checks. It will forward this request to our PC. So the thing, if you see, it's a file of 2 GB. So let's just take one hypothetical number. Let's suppose to download this 2 GB of file between this PC and this server, they have, let's say, exchange around 2000 packets. Let's suppose they have exchanged 2000 packets for downloading this particular file. So the thing is, if you see here, all these 2000 request packet and reply packet will go through all these 27 checks. Means this router will send each and every packet through different processors or different engines, right? It has to send that packet through routing engine, net engine, ACL engine, like ingress processing, ceph table, like it needs to perform so many things. Okay. So here you will see each and every packet is going through all these 27 checks, because router is a stateless device. It is not having any kind of table on which he can see the information and he can allow the traffic, right? Or he can just bypass few checks. In case of router needs to send the packet, either it's a request or a reply, or either this packet belongs to the same flow, it's have to send this packet through each and every time through all these engines, right? So this is the behavior of router. when we have this kind of setup. And router is a stateless device, guys. Okay, now let me just go with the stateful behavior. What is the stateful behavior? Let's suppose I'm having firewall. So this particular thing is valid for every firewall. So I'm having this firewall, but I'll go with the Palo Alto spec. So I'm having here Palo Alto firewall. This firewall have a connectivity through Ethernet 1/1 interface with the server. Same server, this server is running. It's a web server running on port number 80, and it is also having the same 2 GB of file. It's a MP4 file or any file having IP address 151.7.200 or 100. Okay, IP address is 151.7.100. On this interface, I'm having IP address 151.7.250, and this is my outside interface. This is my inside interface. Interface Ethernet 1/2, and I am having here my PC1, and this PC having IP 10.1.1.100, and this interface having IP 250. So I'm having this kind of setup in case of now firewall. So now similar thing, what it will do now, this PC again wants to download this particular file from this server. So what it will do, he will just forward the request. It's a first packet, it's a TCP SYN, and so what, when router receive this packet on this interface, so what it will do, so router put this packet into the ingress state, guys. Ingress stage, and after that, when it processing at the ingress level has been completed, after that this particular firewall put this packet, because it's a first packet, into though your connection setup stage. Okay, what are the things we have in ingress stage? We will cover everything, don't worry, guys. Okay, so in connection setup state, generally it will include your routing table lookup. It will include your net table lookup. It will include your security policy lookup. There are other things also there, but these are the main engines actually which we have in connection setup state. When the connection setup state has been completed for this packet, what it will do, after that this packet will go for the connection table, or we can say session table. This is known as like fast path. I will explain you guys everything. Okay, don't worry. Connection setup state is known as a slow path. And after that, this packet will go for the app identification. Then this packet go for the content identification. And after that, this packet will go for egress process. Okay. So the thing is, when your egress process has been completed, this particular request go till this server. It's a first packet, guys. And the thing is, when my firewall is processing this first packet, the major checks which is done by the firewall, which really takes some time, because in firewalls we will have so many net rules, we have so many security policies, right? We have a routing. These are the main engines, we can say, of a firewall, which really takes some time, guys. Okay, so the thing is, this is the behavior with the first firewall. Now when this server give the reply, this is the reply packet from first packet. What in that case, what my firewall will do? My firewall just process the packet in this way. What it will put the packet into the ingress state, and it will completely bypass this particular connection setup state, because when this firewall process this first packet, what it has created the connection detail into the connection table, guys. This table is also known as a session table. Connection table, session table, state table, names are maybe a different names, but things are similar, guys. Okay, because my firewall have a entry in a session table. So, and according to this session table, what it will do, it will just bypass these checks, these particular major check. It will just process the packet through ingress check, connection setup state, app ID, content ID, and egress processing. Okay, and he will process, he will just send the reply here. When second packet will go, for second packet also it will bypass this particular connection setup stage. So the thing is, now you can relate like stateful inspection. Due to the stateful inspection, like inspection behavior of a network device is completely changed, guys. Like router, they are completely bypassing the connection setup state, and when they will bypass this state, which means they will save some resources, right? Because when you do the lookup on routing table, when you process the net rules, when you process the security policies, it will consume your CPU, it will consume your RAM, right? And it will also, because they are bypassing this state, they are only do performing the lookup on session table. So the thing is that processing time will also increase due to this stateful inspection, guys. So in stateful inspection, your firewall basically create a state table, and it will basically allow the remaining request and reply packets, or it will process the remaining request and reply packet for the same flow by looking into the connection table, or we can say into the session table, and it will completely bypass the connection setup state. In connection setup state, major lookups like routing table lookup, net table lookup, security policies lookup will be totally completely bypassed, guys. Okay, now what we will, so this is how basically your firewall deal with these packets. Now what I can do, let me just erase few things here. So I will remove these things. Okay, okay. So now when this PC initiates the request over this server, what it will do, it has a created a packet like this. In packet source IP address is 10.1.1.100. Destination IP address is 151.7.100. This is the destination IP. Source port is 1234. It's a random port. Destination port is 80. This is destination. We are having here some data. This particular packet reaches to the firewall. So what my firewall will do? It will just get the information from this packet, and in Palo Alto firewall, Palo Alto create two things. It will create a flow from client to server, and one flow it will create from server to client. And what it will put into this particular flow, it will put the information of like source IP address, it will put the information of destination IP address, it will put the information of protocol, what is the layer 3 protocol. So in case of TCP, protocol number is 6. In case of UDP, protocol number is 17. So because here they are accessing a TCP request, so it will put this protocol number 6. It will also put the information of source port number and destination port number. And it will also put the ingress zone information, guys. So these are the 6 tuples which is saved into the session table of an Palo Alto firewall, guys. So sometime in interview, maybe they will ask like, what are the information which is available in a session table? So you have to request in this way. What is the client to server flow or server to client flow? In server to client flow, what? It will have a similar information, but he will swap that information. Source become destination, and destination becomes source port become destination port become source port. So it will just swap that information, guys. Okay, so let me now just go in little bit some more details, guys. So this stateful inspection, this particular concept is developed in 1993. The person name he who has developed this concept is Nirzuk. Why I'm telling this story? Because he's a founder and he's the developer of Palo Alto Firewall, guys. So the thing is, 1993, Nirzuk is a part of Checkpoint Tech team. That time he have basically developed this particular technology. And after 1994 onwards, other vendors like Cisco, ASA and all, they have start basically using this stateful inspection, guys. Okay, so this Nirjuk first he's a part of NetScreen, and after that he just moved towards Checkpoint, and after that he left Checkpoint and he had just started developing this Palo Alto firewall, and he has launched Palo Alto firewall in 2002. But due to some reason this firewall is not succeeded, and after that in 2005 he will come with a new feature set. What are the new feature sets? So that time Palo Alto is the first firewall who is having the support of application identification. That the first feature, and that's the first firewall who have a support of content identification. Means all these functionality is available in a one box solution. It's a one box solution that time, and it will also have a feature set which is user identity. You can write the user based policy. So due to these kind of feature set, guys, Palo Alto become very popular. And due to its architecture also, because Palo Alto having a SP3 kind of architecture. SP3 stand for single pass software parallel processing hardware. Due to this kind of architecture also, I will explain what is this SP3 in details, don't worry guys. Okay, so this is the some little bit history of this particular, we can say, Palo Alto firewall. Now let me just go into my whiteboard. Let me just get one image here. So guys, if you see here, due to these particular feature sets, your Palo Alto become number one firewall. App ID, user ID and content ID. Content ID includes your threats, URLs, which is like web filtering or URL filtering. Threats include vulnerability protection, virus protection, spyware protection. Data protection will basically protect you from the command and control kind of attacks, right? These kind of files you can blog. These kind of features are there actually in Palo Alto, guys. Okay, so due to this particular feature sets, your Palo Alto become the number one firewall that time, guys. Okay, now if I'll go into this image and not on this one, let me just go into my notepad. So this is guy your stateful inspection. Okay, now let me, we have also covered this Palo Alto history. This is the only history behind this Palo Alto. Now let's discuss this Palo Alto operating system. Okay, so the thing is, Palo Alto operating system is known as like Pan OS. Okay, operating system of Palo Alto is known as a Pan OS. The latest version of Pan OS is 10.x. Okay, now what Palo Alto have done, they have just take the BSD Linux. This is the open source Linux flavor. They have taken this BSD Linux. They have just do some customization on this particular operating system. And on top of this BSD Linux, they have just put the Pan application. And the entire thing is basically your Palo Alto firewall, which is your Pan OS. So the thing, if you see here in the core, actually they are running Linux, right? So the thing is, in a backend of your Palo Alto, it will basically runs the Linux processes. Linux daemons is running. So the thing is, when we will have a T-suite class, I will go through with these daemons process and all, how we can control these process and other steps, right? And this Pan application, because this when you will run the Palo Alto firewall, when you boot up your Palo Alto firewall first, Linux will basically boots up, it will come up, and on top of this Linux, after that your Palo Alto application will start. Okay, so all your Palo Alto services is running on top of this Linux box. Okay, now if I'll talk about the Palo Alto hardwares, guy, so like Palo Alto have a both kind of hard devices, like it is having hardware devices, it is also having the BM series devices. So both kind of devices is available in case of Palo Alto, guys. So let me go into this picture. So if you see here, these are the few hardware devices like we are having PA 200. This particular, it's a like first firewall, and that firewall we will use in a small organization where we are having user count from 0 to 200, means where we are having very less users count. So this is for a small organization or a small business units, guys. After we are having like PA 800 series, then we are having PA 3200 series. These are the like these particular devices we will use with the medium size organization or with the enterprise level customers, guys. And after that we will, Palo Alto is also having like PA 5200 series and PA 7000 series. These are the hard, these are the data center level devices where we are having a huge traffic, maybe where we are receiving traffic in GBs, maybe we are receiving traffic like 10 Gbps per second, right? In that case we will go through these particular data center level devices. So these are the few hardware models of your Palo Alto firewall. Let's suppose you want to deploy your Palo Alto firewall into AWS cloud or into Azure cloud or into GCP cloud or into Red Hat OpenStack. For that also Palo Alto having the images, guys. You can install these images over the VMware, over the KVM, Citrix, Amazon, Azure, Google Cloud, Oracle. For almost all these kind of clouds, Palo Alto having these images, guys. You can install these particular virtual flavors as well, like VM 1000, then VM 200, VM 300, VM 1000, hypervisor. They have a, like these are the values of throughputs and all. You don't need to remember all these throughputs and all, guys, because let's suppose you got a request from the customer. Now you have to prepare the BOM, bill of material, right? In that case you can collect the information like what is the throughput the customer is having in a current environment, what kind of application they are having, what kind of Palo Alto services they want. According to these things you can basically choose the appropriate model number, guys. Okay, and you can get all these details into the Palo Alto website. Let's suppose you can go to into PA 3200 series box or maybe into this box, right? Let me just go there. You can look for here you will get all the details like app ID throughput, app ID firewall throughput, threat prevention throughput, connection per second, right? All these details you will get. So we don't need to remember anything here, guys. It's totally depends on you. What are the customer requirement? According to their requirement, we will go to into the Palo Alto networks.com and we will basically get the data sheets of our devices over there, and accordingly we will basically choose the appropriate model number. Okay, so this is how we basically choose the devices, guys. Okay, you will see if I'll go into the last, you will get some like VM devices or VM series devices also there. CN series is also there. Okay? Go into third page, you will get all these details here, guys. If you want, you can just get the details from here. Okay. Now, now what I can do, let me also complete your SP3, and after that I'll give a time for question and answer, guys. Okay. So for SP3, what I can do, I will take a help of one picture, guys. Always I will take a help of these pictures because you will understand the things in a proper way. So I will just open this diagram first. So first of all, let me just explain you what is SP3. So SP3 stand for single pass software and parallel processing hardware. That is the full form of your SP3. Single pass software and parallel processing hardware. So what do you mean by the single pass software? So if I'll go into this image here, okay. So the thing is, if you see, this is the internal architecture of your Palo Alto device, guys. Where, so in this particular diagram, you have seen Palo Alto have generally it is having these three processor. network processor, security processor, and content processor. Or you can think like this is your networking engine, then security engine, and then content engine, guys. These are the engines which basically process your data traffic or the request from the users. And Palo Alto is also having the management engine, or we can say management processor, who will take care of your management part. And on top of this particular processor, we are running the Palo Alto operating system, right? PAN-OS. So the thing is, in Palo Alto, what happens when Palo Alto receives a packet from any machine? What it will do? It will first put this packet into the networking engine. It will put the packet into the networking engine, like in this diagram you will see. We are receiving the packet. That packet is received at the networking engine, or we can say at the switch fabric. Okay, it will receive that packet here. It will just do the networking related stuff like L2 L3 networking, HA, config management, or reporting. All these networking stuff is done by the net, is also part of your networking engine. All these thing is done by the networking engine. And after what it will do, when networking engine is complete their process, it will send this packet towards the user ID. If we are using user identification, so here basically user identification will happen. And after that, that packet go for the application identification, where your application identification happens. Means my firewall is try to identify the applications, guys. And after that, that same packet go for the content identification, where the where your antivirus, anti-spyware, malware, these kind of threats will be detected, guys. Or URL filtering is also, wildfire is also part of this content identification. And after that, your packet will go for the policy engine, guys. So this is how my firewall process the packet at the hardware level, guys. Means it will receive the packet. First he will put that packet into the networking engine, then user ID, then app ID, then content ID, then policy engine. It will after it will just forward this packet from the outside interface. Okay, now the thing, if you see here, Palo Alto also have divided its hardware into two parts actually. First part is control plane and second part is data plane. And if you see here, this particular data plane is having a dedicated, is also further divided into three planes, which is networking, security, and content, right? And these particular processor or engines, they will have dedicated RAM and CPU. So means now these particular processor dedicatedly basically working on their own jobs, guys. Means if let's suppose my Palo Alto firewall wants to perform the networking related stuff, that is stuff done by the networking engine. Then if my firewall wants to match the do the security policy lookup, that thing policy processor will work. If my firewall wants to threats scan for the threats and all, it will, in that case will do the that thing done by this content processor. Or we can say networking processor, security processor, and signature match. Content is equals to your signature mesh. Security processor is responsible for session lookup, SSL, IPsec, and decompression. Networking processor is responsible for flow control, route, ARP table, MAC lookup, quality of service, and net. And if you see here, all these particular processors, they are having dedicated RAM and CPUs, right? So they don't have any kind of resource level dependency. Because they don't have any kind of resource level dependency, they can basically process their requests independently. But in other firewalls, what will happen? They will have us, they will support some kind of shared resource kind of architecture, where let's suppose someone have launched the routing flood attack into your routing table. In that case, maybe your routing engine will consume all your RAM and CPU, and your other engines, they will not able to process your request. But that will not happen in case of Palo Alto. If your router engine is over consumed, it will not harm your security processor or your signature match processor. That's the one benefit due to its architecture. This is known as like parallel processing architecture, because these engines can process the request parallelly. They don't have any kind of resource level dependency. And the thing is mainly your sp3. When I talk about the sp3, your sp3 mainly basically come in a picture when basically your content identification happens. Let's suppose my firewall needs to inspect the traffic for 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 anti-spyware, for vulnerability protection, for data protection, for URL filtering, right? For data filtering, and I'm having all these particular signature database here. So what it will do generally, when due to this sp3 architecture, my Palo Alto firewalls do the streamlined signature mesh, guys. For all these signature, it will perform the lookup in one go, guys. It will not repeat any kind of engines. Okay, it will just perform the stream based signature match for identifying the threats, malwares, exploits, these kind of things. And your sp3 in actually it works at the content identification level, guys. Okay, so this is the architecture of your Palo Alto firewall, guys. And if you see here, because Palo Alto have divided their data plane and control plane, so if let's suppose someone have launched the DDoS attack in your data plane, what you can do? In that case, your management plane will not hamper. You can log in through your management plane because RAM, CPU, and SSD, it is having dedicated RAM, CPU, and SSD in the management plane, or we can say in the control plane. You can log in through your management plane, configure the security rule for against this attack. And let's suppose sometime if your management plane having some issues, maybe commit is failing, or maybe some kind of daemon. Let's suppose you due to this we are having one daemon which is Ike Manager. That daemon is responsible for your IPsec site to site VPN. Let's say if this daemon process failed, or maybe let's say there's a one process which is authentication daemon auth d. Let's say this you are having issue with the authentication, or maybe when we are having a issue with the commit actually, or maybe we are having issue with the logging, means my firewall is not able to generate the logs properly. So in that case, what we have to do? Sometime in other firewall, we have to just restart the entire device. But that's not a case with the Palo Alto. In Palo Alto, what we can restart these management level processes, individual process we can kill and we can restart. Sometime let's say due to some bug and all in the operating system, maybe some process is basically creating some problem, maybe it is consuming lots of RAM and CPU. Due to this particular process, some kind of basically issues are coming. In that scenario, you can just kill these kind of process, you can control that thing at the daemon level. So you can also get the functional, you can restart your management plane only. Let's say you have issues in your data plane, you can restart your data plane only, you don't need to restart entire box. So these kind of flexibility also you will get due to this sp3 architecture, guys. This is single pass software and parallel processing hardware. So these are the benefits you will get in the Palo Alto firewall due to its architecture, guys. Okay, let me just go into the another image, which is this one, where you will get some more details as well. So if you see into this image, guys, so Palo Alto hardware have generally two basically planes, control plane and data plane. Control plane is responsible for configuration management, logging and reporting. Your data plane is responsible for your processing the data, right? That data plane further divided into the signature match processor, security processor, which is a multi-core processor, guys, and the network processor. Okay, and the thing is, this network processor is responsible for quality of service, net, route lookup, ARP lookup, MAC address lookup. This and the security processor, it's a multi-core processor, guys. If you see here, it's having dedicated RAM and CPU, which is responsible for your security policies processing, your IPsec VPN decryption and encryption, your SSL decryption and encryption, your decompression, all these things done by the this particular security processor, which is a multi-core processor, guys. And after that, we are having data plane. Data plane is also having This particular signature match processor is responsible for threats, malwares, URL filtering, it will scans that traffic against antivirus, anti-spyware, all these kind of things. And it is also having dedicated RAM and CPU, guys. And this is the control plane who is having dedicated control plane who is having multi-core CPU with RAM and hard disk for your config management, for your log management, for the reporting purpose. So this is the one more image, guys. Let me also go to into the another image which will clear your picture, guys, here. Okay, so if you see, this is the architecture of your Palo Alto 500 series device. So sometime in interviews, maybe you will come across this switch fabric as well. Maybe they will ask what is switch fabric. So the thing is, these are the hardware level devices. So these are the data center level devices. And in that devices, you will get some kind of switch fabric who will basically responsible for receiving your request, and it will basically provide around 80 Gbps of interconnection. Means it will responsible for receiving your request, processing your request very fast. And also in some model, some high model, you will get dedicated SSL engine, guys. Dedicate SSL engine who will basically do the SSL decryption dedicatedly. Okay, so if you see in this diagram, it is having like network processor, security processor, and your signature match processor, and this is your data plane. So this is the architecture of your PA500 series device. And they will basically also, if they want to communicate with each other, they are having around 100 Gbps of internal communication chains due to this switch fabric, guys, because these engine also needs to communicate with each other by using the electronic signals and all. Okay, if network engine wants to communicate with the security processor, what they will do, or a pulse engine, it will basically they can communicate by using the 20 Gbps of data, guys. So these kind of things are there, guys, in the high end boxes. So sometimes they you if you come across these kind of images or this kind of question, you can able to answer them in a proper way, guys. So so these are the things which I want to discuss in your day one, part one, guys.